Hello, and welcome. Let's not start out there in the vastness of space, let's start right here. In this room, in this moment, just breathe. Take a slow deep breath in, filling your lungs with the quiet of the night. Hold it for just a moment, and now let the day go with it. All the noise, all the hurry, all the lists of things done and things yet to do, let them be. They are not for now. Now is a time for stillness, a time for release. Feel the weight of your body supported and held. Feel the gentle pull of gravity, a constant reassuring presence reminding you that you are safe, you are anchored to this world. As your body softens, let your mind begin to drift. Let it float. When you are ready, imagine yourself looking up, not at a ceiling, but at a perfectly clear dark night sky. For so much of our history, we have seen this as a roof, a black velvet ceiling perhaps punctured by tiny lights, a wall that separates us from something else. But tonight, let's see it for what it truly is. It is not a wall, it is an ocean. A vast, silent, cosmic ocean, deeper than we can imagine, stretching out into infinity. And we are standing on the shore, our world, our homes, our lives. Everything we have ever known is just the sand beneath our feet at the edge of this endless starry sea. Tonight, we are not going on a difficult journey. We are not launching into the void. We are just going to stand here at the water's edge, to feel the gentle pull of the tide, to let our minds float away from the shore just a little and see what we find in the quiet currents of space. This shore we stand on, we call it Earth. It is our island, our oasis, our one precious home floating in the great dark. For thousands and thousands of years, we believed it was the center of everything. It felt that way, didn't it? The ground is solid, the sun rises and sets moving around us. The stars wheel overhead in predictable patterns. We believed we were the fixed point, the purpose of it all. But the truth we learned is perhaps even more beautiful. We are not the center. We are a starting point. We are a rare and wonderful accident of physics and chemistry. Think for a moment about what makes this shore so special. Think about the water, the great oceans of our world, the Pacific, the Atlantic, the Indian. They seem so vast, so powerful. But in the grand scale of the cosmos, this water is one of the rarest substances there is. We search the stars for it. We look for the chemical signature of water on distant planets and frozen moons. Here it flows. It falls from the sky as rain. It gathers in rivers. It carves the great canyons. It freezes into silent blue glaciers. And it flows through us. We are born of this water. We are ourselves walking oceans. And then there is the air. The very breath you are taking right now, this atmosphere. We walk through it every single day and barely notice it like a fish in the sea. But if you could float away just a little, you would see it for what it truly is. It is a membrane, a skin. It is the thinnest, most delicate layer of gas clinging to our planet only by the gentle persistence of gravity. If the Earth were the size of a polished apple, our entire atmosphere, all the air we have ever breathed, would be thinner than the skin of that apple. Think of that. This fragile blue film is all that stands between us and the vacuum. The endless silent cold of space. Just outside this thin bubble, the temperature plummets to hundreds of degrees below zero. There is no pressure. There is no sound because there is no air to carry it. Just a profound, unending schwantz. But here, we are protected. This thin layer of nitrogen and oxygen catches the harshest radiation from our sun. It holds in the warmth like a blanket. It holds the clouds and it holds the weather. It holds all the sound, all the music, all the whispers, all the life. This planet is not just a rock. It is a garden. It is an ark. It is a tiny, precious living world adrift in an ocean of emptiness. It is our home. For all of human history, we were bound to this shore. We could only look up at the cosmic ocean. We could chart the stars, we could tell stories about them, but we could never leave the sand. And then, just a whisper of a moment ago in cosmic time we did. We built ships, vessels of fire and metal, and we left the shore. We sent people floating out into that dark ocean, and when they got there, when they were truly adrift in the void, they turned and then they looked back. They saw something that changed them forever. They saw our home, not as a map, not as a collection of countries or borders or lines drawn in the sand. They saw it as one thing. They call it the overview effect. It is a feeling, a sudden powerful shift in perspective that astronauts describe, a feeling that is almost impossible to explain. But let's try. Imagine yourself there, floating in perfect silence. You look out the window and there it is, perfect shining sphere of blue and white and brown. A marble of impossible beauty hanging in the absolute total blackness. You see the whole thing, you see the curve, the distinct clear edge of the world, you see the paper-thin electric blue line of the atmosphere glowing against the dark. You see the continents not as political shapes but as geographic truths. You see the green of forests, the tan of deserts. You see the colossal swirling patterns of clouds, systems of weather, moving silently across the globe. You can see lightning flashing like tiny sparks inside those clouds. At night you see the cities lit up like clusters of jewels. From up there you cannot see the borders, you cannot see the walls, you cannot see the arguments, the divisions, the things that separate us. You just see home. One single unified, breathtakingly beautiful home. Astronauts have said that they went to space to explore the moon, but what they truly discovered was the Earth. They felt an overwhelming sense of connection, a feeling that this tiny blue dot is all we have. That is the overview effect. It is the sudden, deep and quiet realization that we are all on this ride together. We are all crewmates on this tiny, fragile spaceship journeying through the dark. All of our history, everyone you have ever loved, every song ever sung, every war ever fought, it all happened right there, on that beautiful, fragile oasis, that dot of light. But for now, our journey is just beginning. We are still here safe on the shore. The cosmic ocean is quiet and the stars are just beginning to shine. There is no need to explore it all tonight. There is no rush. The universe has been here for billions of years, and it will be here tomorrow. For now, just rest. Rest here on the sands of Earth. Feel the safety of our atmosphere, the gentle pull of our planet. Let your mind be as calm as the deep dark sea of space. Let the question drift. Let the answers wait. There is only the breath. In and out. The gentle tide of your own breathing. Drifting, floating, sleep. When you step outside on a clear night, your eyes are almost always drawn to it. It hangs in the darkness, a familiar glowing disk. Sometimes it is a perfect silver circle. Other times it is a delicate curved sliver of light. This is the moon, the most constant and familiar object in our night sky. It feels so close, like a lamp hung just for us. But it's not just a light. It is a world, a vast, silent, ancient world of dust and rock spinning through space alongside us. It is our companion. We often think of it as just being there, a piece of scenery. But the moon is so much more than that. It is our anchor. Its quiet, invisible pull, its gravity reaches across hundreds of thousands of kilometers of empty space to hold on to the Earth. This gentle pull keeps our planet steady. The Earth spins on its axis, the imaginary line that goes through the north and south poles. The moon's gravity acts like a steadying hand, keeping that axis tilted at a stable angle. Without the moon, the Earth might wobble wildly, tipping over dramatically over long periods. This would cause extreme changes in climate, perhaps making it impossible for complex life to have ever developed. The moon in its silence has made our world a more stable and predictable home. It has also been a silent witness to our entire story. Every human who has ever lived has looked up at this same moon. Our distant ancestors huddled around a fire looked up and saw the same pale face watching over them. Ancient civilizations built calendars based on its predictable cycle, its phases. It has inspired art, poetry and wonder for all of human history. It is the one thing that connects every generation, a timeless mirror reflecting our own smallness and our enduring curiosity. But this calm, steady companion hides a history of unimaginable violence. Its peaceful glow is the scar of a truly catastrophic birth. To understand where the moon came from, we must travel back in time, way back over 4.5 billion years ago. The solar system was a young, chaotic place. Our planet, the Earth, was just a baby barely formed. It was a hot, molten ball of rock still glowing from its creation. It was not alone in its orbit. Another young planet, an object perhaps the size of Mars, was wandering through this early solar system. We sometimes call this lost world Theia, and it was on a collision course with Earth. The impact was an event beyond all comprehension. A world the size of Mars struck the young Earth with a glancing blow. The energy released was greater than millions of nuclear bombs. Theia was completely destroyed. A huge part of the Earth's own outer layer, its mantle was vaporized and blasted into space. For a time, the Earth was surrounded by a glowing, swirling ring of superheated gas dust and molten rock. It would have looked like a fiery version of Saturn. This ring of debris did not float away. Earth's gravity held onto it. And over thousands of years, this cloud of rubble began to come together. Gravity is persistent, small pieces stuck to each other. These new clumps attracted more pieces. The clumps grew into boulders, the boulders grew into mountains, and the mountains pulled together to form one single massive glowing sphere. This new sphere, born from the shattered remains of two planets, was our moon. So when you look up at the moon, you are not looking at a stranger. You are looking at a piece of our own planet. The moon is made of the same ancient materials as the ground beneath your feet. It is bone of our bone, rock of our rock. It is Earth's child, born from the most violent event in our planet's life. After its fiery birth, the moon cooled. Its violent creation is long past, and now it drifts beside us as our quiet neighbour. But its influence is felt every single day. Its main power now is its persistent, gentle pull, its gravity. We do not feel this pull on our bodies, but the Earth's great oceans feel it clearly. The moon is constantly pulling on the Earth. It pulls on the solid rock, but the rock is stiff and does not move much. It also pulls on the vast oceans, and the water is free to move. The water on the side of the Earth facing the moon is pulled toward it, creating a bulge. Interestingly, the water on the opposite side of the ETH is also left behind, creating a second bulge. Our planet spins on its axis once every day. As it spins, the continents and oceans pass through these two bulges of water. When a coastline moves into one of these bulges, the water level rises. We call this high tide. When it moves out of the bulge, the water level falls. We call this low tide. The moon is in essence causing the entire planet to take a slow, deep breath twice every day. This rhythm is ancient. For billions of years, this tidal pulse has washed over the world's coastlines, mixing water and minerals. Some scientists believe this constant gentle rhythm of wet and dry on ancient shores might have been the perfect environment for the very first simple life to emerge from the water and begin its long journey. The moon is not just a pretty light, it is a fundamental engine for the rhythms of life on Earth. And what of the moon itself? What is it like on that silent world? When we look up, we see a face of light and shadow. The bright parts are the highlands. This is the moon's original crust, the oldest rock. It is rugged, mountainous, and absolutely covered in craters. These are the scars from billions of years of impacts from asteroids and comets. The dark patches are what create the features we see as the man in the moon. Early astronomers long ago thought these smooth dark areas were oceans. They gave them the Latin name Maria, which means seas. But there is no water on the moon, not liquid water anyway. These seas are actually vast flat plains of dark volcanic rock like basalt. Billions of years ago, long after the moon formed, the solar system was still full of debris. Giant asteroids, some as large as cities, would crash into the moon. These impacts were so enormous that they cracked the moon's young crust. From deep inside, dark molten lava magma welled up to the surface. It flooded these giant impact craters, filling them like bowls. This lava eventually cooled and hardened, forming the smooth, dark plains we see today. The moon is now a still, quiet place. It is a world of magnificent desolation. Because there is no air, there is no wind to blow the dust around. Because there is no water, there is no rain to wash the land. There is no weather. Nothing ever changes. It is a perfect museum of the solar system's past. The footprints left in the fine grey dust by the Apollo astronauts decades ago are still there undisturbed. They look as if they were made just yesterday, and they will remain there perfectly preserved for millions of years until a tiny meteorite happens to strike them. It is a world of absolute silence under a sky that is permanently black even in the daytime. This is our neighbour. It is not just a rock. It is a piece of our own planet, a reminder of our chaotic birth. It is the steady hand that calms our world's spin. It is the celestial heart that sets the rhythm of our oceans. It is the most familiar sight in our sky, and yet it is a completely alien world. It is our potent ancient companion. For a moment, let us pull our gaze back from the edge of the universe, away from the distant quasars and the mystery of dark energy. Let us return home. This is our neighbourhood, our cosmic cut street, the solar system. Long before we had telescopes, the ancient stargazers noticed something strange. While the background of stars seemed fixed like diamonds pinned to a black velvet cloth, a few special lights moved. They didn't twinkle quite like stars, they drifted with purpose across the sky. The Greeks called them planetes, which simply means wanderers. They gave them the names of their gods, and perhaps they were right to. These are not just lifeless balls of rock, ice and gas listed in a textbook. They are characters. They have personalities, moods and histories. They are our cosmic family. This is the story of our brothers and sisters, the lighthouses that circle our own home star. We start with our neighbour, the one we know best, Mars. If Earth is the blue marble of life, Mars is the dusty red dream of a forgotten past. It is a world of echoes. When we look at Mars, we are looking at a story that has already reached its end. Its colour, that deep rusty orange, comes from iron oxide rust. It is a world that has been slowly oxidizing, freezing and losing its breath for billions of years. We send our robotic explorers there and they send back pictures of vast empty canyons and dry riverbeds. This is the part that haunts us. Mars was not always like this. It once had rivers, lakes and perhaps even a shallow ocean. It had a thicker atmosphere. It was warmer. It was perhaps a cousin to Earth. Where did the water go? Where did the air go? It is a cold, silent desert now, but Mars is also a dream of the future. It is the only other world in our entire solar system that humans can realistically dream of walking upon. We look at its rusty soil and we don't just see an end, we see a beginning. We dream of planting flags, building domes, and perhaps one day hearing the wind whistle not just over dead rock, but over a new human outpost. Mars is our past and our future, a warning and an invitation all in one. We move outward past the belt of asteroids and we meet the king. Jupiter. This is not a planet. It is a giant. It is a monster. If you took every other planet in our solar system and mashed them together, Jupiter would still be more than twice as massive. It is so big it is almost a failed star. Jupiter is our guardian. Its immense gravity, a force so powerful it bends the paths of comets and asteroids, acts as a giant shield for Earth. It catches or throws out the dangerous space debris that might otherwise head our way. It is the solar system's protector. But this guardian is a violent one. Its surface is not solid ground. It is a swirling, boiling ocean of clouds thousands of miles deep. Its weather is eternal. And then there is the eye, the great red spot. This is a hurricane, but a hurricane so vast you could drop 3 entire Earths into it. It is not a storm that lasts for a week. It is a storm that has been raging for at least 400 years, ever since we first pointed telescopes at it. It is less a weather event and more a permanent feature, a giant unblinking eye staring out into the void. And Jupiter is not alone. It has its own family. Its 4 largest moons, Io, Europa, Ganymede and Callisto, are worlds in their own right. They are so large and complex they are often called a mini-solar system. Io is a world of volcanoes constantly erupting sulfur. And Europa is perhaps the most exciting target in our pursuit for life. Beneath its cracked frozen shell of ice, scientists are almost certain there is a vast dark ocean of liquid salt water kept warm by the squeeze of Jupiter's gravity. A dark ocean hidden from the sun. What could be swimming there? If Jupiter is the powerful king, Saturn is the impossible jewel. It is the artist of the solar system. There is nothing else like it. Its beauty is quiet, cold and perfect. The rings. From Earth they look like a solid, graceful halo. But they are an illusion. They are not solid at all. They are made of billions upon billions of individual pieces of ice and dust. Some are as small as a grain of sugar, others as large as a house. They are all spinning together in a dance around the planet, a cosmic blizzard frozen in time. The most incredible fact about the rings is how thin they are. While they stretch for hundreds of thousands of miles across, they are in most places only about 30 feet thick. They are a structure as wide as a continent but as thin as a 2-story building. They are a fragile, impossible piece of architecture. Why does Saturn have them? Perhaps a moon strayed too close and was shattered by Saturn's gravity. Perhaps it is the leftover material from the birth of the solar system that never formed a moon. We don't know for sure. Their beauty is a mystery. They are not necessary. They just are. They are a reminder that the universe does not only build for function, it also builds for beauty. Finally, we journey to the far deep cold. We reach the frontier. Here in the dark live the remote ice giants Uranus and Neptune. These are not like the rocky inner worlds. They are not like the gas giants. They are something else. They are cold, slushy worlds made of water, methane and ammonia ice wrapped in a deep atmosphere. Their colour is a haunting, beautiful deep blue. This blue is not from water oceans like Earth's. It comes from the methane gas in their air, which absorbs the red light from the sun and reflects the blue. Uranus is the strange one, the planet that got knocked over. It spins on its side with its poles pointed at the sun, perhaps from a massive collision long ago. Neptune is the stormy one, a blue world with the fastest, most violent winds in the entire solar system, raging at over 1,000 miles per hour. Out here, the sun is no longer a big warm disk. It is just a tiny, brilliant point of light like an overpowerful star. The light that reaches these worlds is faint, about 900 times weaker than the sunlight we enjoy on Earth. This is the deep end of our home. These worlds are the silent blue sentinels, marking the edge of our family gazing out into the great empty dark that waits beyond. In all our wandering through the quiet dark, we have been orbiting, held in place by, and bathed in the light of the most important object in our neighbourhood. It is the central furnace, the anchor, and the life-giver of our entire system. We are so used to it, we call it the sun as if it were the only one, and for us, it is. Let's journey towards this incredible source of power. When you think of the sun, what do you see? Many of us picture a giant angry ball of fire, a chaotic bonfire in the sky. But this image, while common, isn't quite right. The sun is not burning in the way a log burns in a fireplace. A fire is a chemical reaction. The sun is something far more profound, far more powerful, and thankfully for us, far more stable. Our star is a magnificent and vast nuclear reactor. It is a sphere of superheated gas, mostly hydrogen and helium, so massive that its own gravity, the weight of all that gas, is almost beyond imagination. In the very heart of the sun and at its core, this gravitational pressure is so immense, so crushing, that it forces hydrogen atoms, the simplest and lightest element, to slam together. They are squeezed so tightly that they fuse, merging 4 hydrogen atoms into one new heavier atom, helium. This process is called nuclear fusion. And in that tiny miraculous moment of creation when hydrogen becomes helium, a little bit of mass is left over. This leftover stuff is converted into a pure, staggering burst of energy. This is the energy that pushes outward, fighting back against the crushing gravity that pulls inward. The sun exists in a state of perfect, beautiful balance. Gravity pulls in and the energy from fusion pushes out. This balance has kept our sun shining steadily, not as a chaotic explosion, but as a reliable, gentle furnace for over 4.5 billion years. It is this stability, this gentle and constant release of energy, that is the single most important factor for life on Earth. This light, which began its journey in the sun's core, travels for thousands of years to reach the surface and then takes just over 8 minutes to cross the 93 million miles to Earth. It arrives as sunlight. It is the food for our plants, the energy that drives our weather, the warmth that keeps our oceans liquid. Every bite of food you eat, every breath of air you take is in a very real sense powered by this distant, stable nuclear reactor. But the sun's influence doesn't stop with light and heat. Its power defines the very boundaries of our home in space. The sun is constantly releasing not just light, but also a continuous high-speed stream of charged particles, mostly protons and electrons. This is the solar wind. This wind flows outward from the sun in all directions, travelling at speeds of hundreds of kilometers per second. It rushes past Mercury, past Venus, past Earth and Mars, past the gas giants, and keeps going far beyond the orbit of Pluto. This solar wind inflates a gigantic magnetic bubble in interstellar space. This bubble is called the heliosphere. You can think of it as our solar system's protective shield. Outside this bubble, in the vast empty space between the stars, the galaxy is filled with dangerous high-energy particles called cosmic rays. These are the remnants of distant supernovae, the shrapnel from black holes and other violent cosmic events. They are tiny bullets travelling at nearly the speed of light. The heliosphere, this bubble blown by our sun, pushes back against this interstellar sea. It acts as a shield, deflecting the majority of these harmful cosmic rays, making our solar system a far safer place to live. Here is a thought that may change how you see the sky. The heliosphere is the sun's atmosphere. We are living inside it. We are not just receiving light from a distant object. We are physically enclosed within the outer reaches of our star's influence. The solar wind that flows past Earth is the sun's own breath. We are truly in every sense children of the sun, living inside the protective cocoon it has created for us. This furnace, this shield, this constant presence in our lives feels permanent. It has risen every morning of your life and every morning of human history. It feels eternal. But our sun is a star. And like all things in the cosmos, from the smallest insect to the grandest galaxy, stars have a life cycle. They are born, they live, and they die. Our sun is currently in its prime. It is a middle-aged star, calmly and steadily fusing hydrogen into helium as it has done for billions of years. It is stable, peaceful, and predictable, and it will remain this way for a very, very long time. But it will not last forever. This is a gentle truth, one that should not bring fear but a sense of perspective. In about 5 billion years, a number so vast it is almost meaningless to us, the sun will begin to run low on its hydrogen fuel. When this happens, its perfect balance will be broken. The core will change and the sun will begin to swell and expanding outward, becoming what is known as a red giant. Its end is far away, so distant in time, that human civilization in its current form is just a flicker in the long, lazy afternoon of the sun's life. We will not be here to see it. There is a deep peace to be found in this. The universe is not static. It is a place of cycles. Stars are born from clouds of dust and gas. They live shining for billions of years, creating heavier elements in their cores. When they die, they release these elements back into space, providing the raw materials for new stars, new planets, and in at least one case for life. Our sun is part of this grand cosmic rhythm. It is our anchor, our shield, and our power source. And its story, stretching billions of years into the past and billions of years into the future, reminds us that we are part of something ancient, vast and beautifully cyclical. We have travelled to the edges of our solar system, past the orbits of the gas giants and the icy worlds beyond. Now we pull back. We must leave our local neighbourhood entirely. We accelerate past the Kuiper Belt, that distant ring of frozen remnants from the dawn of our system. We keep going, pushing further into the dark. We are crossing a boundary now, a vast invisible bubble. This is the heliosphere, the sphere of influence blown into space by our sun's own wind. For billions of miles, this bubble has protected us, shielding our system from the harsh radiation of deep space. But we are leaving it behind. We are pushing through the heliopause, the very edge of our solar system, and entering the vast open ocean of interstellar space. The sun, our great blazing star that once dominated our sky, has shrunk. It is now just a bright star, indistinguishable from the countless others. The pull of its gravity is weak here, almost gone. We are travellers now adrift between the stars. And as we look back from this new profound distance, we see our home for the first time. Not Earth, not the solar system. We see the whole thing. It is a city of stars. From Earth, our ancestors looked up and saw a faint milky band of light stretching across the night sky. They called it the Milky Way, a celestial river, or a path for the gods. They were not wrong, but they were only seeing it from the inside. From our vantage point far outside, we finally see its true shape. Our home is not a road, it is a metropolis. A magnificent swirling spiral galaxy. It is a flat spinning disk of stars, dust and gas more than 100,000 light-years across. Great sweeping arms glowing with the light of billions of new stars spiral outwards from a bright dense centre. This is our galaxy, the Milky Way. It is a city of perhaps 400 billion stars, and our sun is just one of them. Where are we in this vast city? We are not in the bustling, chaotic downtown. We are not in the bright dense core. We live in the suburbs. Our solar system is located in a relatively quiet, calm neighbourhood. It's a smaller partial arm called the Orion Arm, or sometimes the Orion Spur. It is a peaceful place nestled between two much larger, grander spiral arms, the Sagittarius Arm and the Perseus Arm. When we look up at the Milky Way from Earth, we are simply looking toward the crowded city centre, or looking through the thickness of our own suburban arm. We are seeing the combined hazy light of billions of distant neighbours. The dark patches within that band of light, the ones ancient astronomers thought were holes in the sky, are not holes at all. They are the dark, dusty alleys of the city, impossibly vast clouds of interstellar dust that block the light from the stars behind them. Our suburban location is likely crucial to our existence. Life needs time, life needs stability. Here in the Orion Arm, we are far enough from the chaotic centre to be safe from the intense radiation and the gravitational jostling that would tear our solar system apart. We are in the Goldilocks zone of the galaxy itself, not too close, not too far. Let us leave our quiet home and take an imaginary journey toward that chaotic centre. We fly past billions of stars. The closer we get to the middle, the more crowded it becomes. The space between stars, which is vast in our neighbourhood, begins to shrink. Here stars are packed thousands, even millions of times more densely. The sky would not be dark, it would be a blinding, continuous blaze of starlight. The radiation from so many stars, so many dying stars and supernovae is immense. It is a beautiful, terrible and violent place. We push on toward the very nucleus of our city. The light becomes a furious, swirling fog. We see stars orbiting something at unbelievable speeds. We see stars moving at percentages of the speed of light, whipped around in tight, frantic orbits by a force we cannot see. They are a swarm of bees, all tether-fed to an invisible point. And then at the very centre of this blinding chaos, there is a point of perfect, terrifying silence. It is a void, a spot of absolute darkness in the middle of the brightest place in our galaxy. All the light, all the gas, all the energy swirls around this point like water spiralling down a drain, but nothing ever comes out. This is the invisible heart of our city. Scientists call it Sagittarius, a star. It is a supermassive black hole. It is not just any black hole. It is a monster, a cosmic titan. It has the mass of more than 4 million suns, all crushed down into a single point of zero volume. Its gravity is so intense that nothing, not even light itself, can escape its grasp once it crosses the event horizon, the point of no return. The silence we sense is the silence of light being devoured. The silence is the complete absence of information from beyond its edge. This dark, silent heart is the anchor for our entire galaxy. It is the invisible force that holds our city of 400 billion stars together. Its immense gravitational pull is the engine that dictates the grand spinning dance of the spiral arms. Every star you see, every planet and our own small blue world in the quiet suburbs of the Orion Arm, we are all in orbit around this single dark, silent point. We are all passengers in this great spinning city of stars tethered by gravity to an invisible monster 4 million times the mass of our Sun. The life and death of stars. When we look at a photograph of a spiral galaxy like our own Milky Way, we see beautiful glittering arms curling out from a bright centre. These arms look like they are painted onto the sky, but they are places of incredible activity. They are not static, they are dynamic, flowing structures like cosmic rivers of gas dust and stars. And it is inside these spiral arms that we find the most important places in the universe, vast swirling clouds of gas and dust. We call these clouds nebulae. From our spot here on Earth, they look like faint fuzzy patches of light or dark smudges that block the stars behind them. But if we could travel to them, we would see they are immense, stretching for many light years across. A single light year is the distance light travels in 1 year, an enormous distance. These clouds are cold, dark, and mostly empty by earthly standards, yet they hold all the raw ingredients for creation. These ingredients are mainly hydrogen, the simplest and most common element in the entire universe. Mixed in with the hydrogen gas are tiny particles of dust like fine smoke. For billions of years, these clouds can drift through the dark, cold space between the stars. But they are not idle. They are slowly, patiently being drawn together. Gravity, the great sculptor of the cosmos, is always at work. The spiral arms themselves are like cosmic traffic jams. As stars and gas clouds orbit the centre of the galaxy, they tend to slow down and bunch up when they pass through these arms. This crowding is the first critical step. It allows gravity the time it needs to pull this scattered material together. These dark, silent clouds are not empty. They are full. They are reservoirs of potential waiting for the right moment, the right little push to begin the process of building new worlds. They are both the beginning and the end. They are the places where stars are born, and as we will see, they are also the places that are enriched by the death of stars. It is a grand, endless cycle of recycling. Stellar nurseries. So what is that push that turns a cold, dark cloud into a blazing star factory? It all comes down to gravity. As the cloud drifts, some parts of it are just by chance a little bit denser than other parts. A little more material here, a little less there. Gravity, being the patient force it is, pulls on these denser regions. It whispers, "Come together," and they do. Slowly at first, then faster and faster, a great collapse begins. The cloud fragments into smaller spinning clumps. This is not a gentle process, it is a magnificent, chaotic and powerful event. We call these active collapsing regions stellar nurseries. When you look up at the winter sky and see the constellation of Orion, you might notice a fuzzy-looking star in his sword. That is the Orion Nebula. You're not looking at a cloud. You're looking through a window into one of the most active starbirth regions near us. You're in a very real way looking at a hospital nursery for baby stars. Inside that beautiful glowing gas, thousands of new stars are being born right now. As the gas and dust in one of these clumps collapse, it spins faster like an ice skater pulling in their arms. The pressure at the centre builds up to unimaginable levels. It gets hotter and hotter, climbing to millions of degrees. The centre of this collapsing clump becomes a protostar, a star that is not yet shining with its own power, but it is glowing fiercely from the heat of its own creation. Finally, a critical point is reached. The hydrogen atoms at the very centre can no longer resist the crushing pressure. They are forced together so powerfully that they fuse. They join together to become a new element, helium. In that inexorable, breathtaking moment, a new light flashes into existence. A star is born. The nuclear furnace is lit. This process, nuclear fusion, is the same process that has powered our own sun for 4.5 billion years. The new star's powerful light and wind blast away the remaining gas and dust from its cocoon, revealing itself to the galaxy. The nursery has delivered a new sun. A glorious death, supernovae. But the story of a star is not just about its birth, it is also about its life and its death. And just as in life, not all stars are created equal. Small stars like our sun live long, steady lives for billions of years. They are calm and reliable. When their time finally comes, they will die relatively gently. They will swell up, puff off their outer layers to create a beautiful ghostly cloud called a planetary nebula, and leave a tiny cooling core, a white dwarf, behind. But the giants of the cosmos, the massive stars that are born with dozens of times more material than our sun, their lives are very different. They are the blue-white titans of the galaxy. They live fast, burn their fuel at a ferocious rate, and die young, often in only a few million years. And when their time comes, there is no gentle fading. There is an explosion so bright it defies imagination. We call this event a supernova. In its final moments, the massive star's core runs out of fuel. The nuclear fusion that held it up against the crush of its own gravity suddenly stops. Gravity which it had been fighting its entire life wins. The core collapses in on itself in less than a second. It then rebounds in a titanic shockwave that blows the entire star apart. For a few weeks, this single exploding star can outshine its entire home galaxy, which contains billions of other stars. It is the most powerful explosion the universe ever creates. It looks like the ultimate act of destruction, but it is not. This glorious death is, in fact, the ultimate act of creation. The deep connection. Why is this explosion creation? Because of what happens inside that star just before it dies. The universe was born with only the simplest, lightest elements, mostly hydrogen and a little helium. For the first hundreds of millions of years, that's all there was. Every other element, all the stuff that makes up our world and our bodies, had to be made somewhere. It was made in the fiery hearts of stars. During their long lives, stars fuse hydrogen into helium. Massive stars go further. When they run out of hydrogen, they start fusing helium into carbon. Then they fuse carbon into oxygen, neon, and silicon. They build up heavier and heavier elements in their core like layers of an onion. But it is only in the final, fiery moments of a supernova explosion that the conditions become extreme enough to forge the heaviest elements of all. The blast is so energetic it instantly creates iron, gold, silver, lead, and uranium, every heavy element you can name. That supernova blast doesn't just destroy the star, it seeds the galaxy with these new precious materials. It scatters them far and wide like a farmer scattering seeds. This stardust enriches the next generation of gas clouds. This new material mixes with the hydrogen in those cold, dark clouds which will one day collapse to form new stars and this time new planets. And that is our connection. That is the deep link. Think about this for a moment. The calcium that makes your bones strong, the carbon in your skin and muscles, the iron in your blood that carries oxygen to your brain. Every single atom of those elements was forged billions of years ago inside the heart of a massive star that lived, died, and exploded. That material travelled across the galaxy for eons, eventually finding itself in a cold, dark cloud that collapsed to form our sun, our planet Earth, and everything on it, including you. You are not just living in the universe. The universe is living in you. We are quite literally made of stardust. We are the children of the stars. We are the universe become aware. So far we have journeyed from our small blue planet past the fiery gates of our sun, and across the unimaginable emptiness between the stars to the very edge of our own Milky Way galaxy. We have seen its spiral arms, its glowing core, and its silent dark halo. It feels like the end of the journey. It feels like we have reached the edge of everything, but now we must take the biggest leap of all. We must pull the camera back further and further until our entire galaxy, this sprawling city of 400 billion stars, begins to shrink. We watch as the magnificent spiral arms fold into themselves. The bright central bar fades. The whole glorious Milky Way becomes a bright spinning disk, and then a pinwheel, and then just a single lonely point of light. And as it shrinks, we suddenly see that it's not alone. We are surrounded. What we once thought was the entire universe is just one speck of light in a cosmic ocean. This ocean is dotted with other specks, other points of light stretching away in every direction as far as we can possibly see. Each point of light is another galaxy. This is the galactic archipelago. An archipelago is a chain of islands. In the vast dark ocean of space, the galaxies are the islands. Each one is an island universe, a self-contained city of stars, gas and dust separated from its neighbours by millions of light years of cold, empty intergalactic space. How many are there? For the longest time we had no idea. We thought the fuzzy patches we saw in our telescopes were just clouds of gas inside our own galaxy. but in the 1920s astronomer Edwin Hubble proved that they were impossibly far away. They were other galaxies just like ours. To find out how many astronomers performed one of the most profound experiments in human history. They pointed the Hubble Space Telescope at a tiny black, completely empty patch of sky. It was a spot smaller than a grain of sand held at arm's length, and they just let the camera's shutter stay open, collecting the faintest, oldest light possible. What they found changed everything. In that one tiny, empty spot, they found not stars but thousands of galaxies. Some were spirals like ours, some were massive football-shaped ellipticals, and some were small, messy, irregular shapes. Based on this, we now estimate that in the observable universe there are at least 2 trillion galaxies, 2 trillion islands of light. It is a number so large, the human mind simply cannot hold it. With so many neighbours, where do we even begin? Let's start with the one closest to home. If you're in the northern hemisphere far away from city lights, you can see it with your own eyes. Look towards the constellation of the same name and you will find a faint, fuzzy, elongated smudge of light. It is the most distant object the human eye can see without help. That smudge is not a star, it is not a cloud, it is the Andromeda Galaxy. It is our sister galaxy. Andromeda is what our own Milky Way would probably look like if we could see it from the outside. It is a magnificent spiral, even larger than our own, containing perhaps 1 trillion stars. It is 2.5 million light years away. The light you see when you look at that smudge left Andromeda, 2.5 million years ago, when our earliest human ancestors were just beginning to walk on the African plains. But this sister galaxy is not just sitting there. It is part of a slow, majestic cosmic dance, and it is a dance that is bringing it closer. Pulled by the relentless, invisible force of gravity, the Andromeda Galaxy is hurtling towards our Milky Way. It is moving at a speed of over 200,000 miles per hour. Right now, it is still millions of light years away, but the gap is closing every single second. In about 4.5 billion years, this slow dance will reach its climax. The 2 largest galaxies in our neighbourhood will meet. This is often called a collision, but it is not a crash in the way we think of it. Space is so vast that when these 2 galaxies merge, it is very unlikely that any 2 individual stars will actually hit each other. Instead, it will be a gravitational merger. The 2 giant spirals will pass through each other. Tides of gravity millions of light years long will stretch and pull. Great arms of stars and gas will be flung out into deep space, forming spectacular streamers. The 2 supermassive black holes at their centres will begin to circle each other, closer and closer until they too combine in a cataclysmic event. After passing through, gravity will pull them back together. They will pass through each other again and again over hundreds of millions of years, scrambling their beautiful spiral structures. All the while, the immense clouds of gas from both galaxies will slam into each other, triggering a spectacular burst of star formation. The night sky for any observers at that time will be set ablaze. It will be a swirling, chaotic, brilliant canvas of new stars being born. And when the dust settles, the Milky Way and Andromeda will be gone. In their place will be one new gigantic football-shaped galaxy. Astronomers have already given it a nickname, Milkomeda. It is a reminder that the universe is not static. It is not finished. It is a place of constant, slow and powerful creation. But Andromeda and the Milky Way are not alone in this dance. They are just the 2 largest members of our own cosmic family. Just as stars form in clusters, galaxies also huddle together in groups. Our little galactic neighbourhood is called the local group. It is a small club of galaxies all bound together by their mutual gravity. They are all in a sense trapped in this shared gravitational embrace, destined to orbit each other and eventually merge. The local group is about 10 million light years across. The 2 parents or heavyweights of the family are of course our Milky Way and Andromeda. They dominate the group. But then there are the children. Surrounding us are dozens, at least 80 of smaller dwarf galaxies. If you are in the southern hemisphere, you can see 2 of them very clearly in the night sky. They look like 2 faint detached pieces of the Milky Way itself. They are the large and small Magellanic Clouds. These are 2 small irregular galaxies that are satellites of our own. They orbit the Milky Way just as the Moon orbits the Earth. Andromeda has its own set of satellite galaxies too. And then there is the little brother of the group, the Triangulum Galaxy. It is the 3rd largest spiral, but much smaller than either OS or Andromeda. This is our home. We are not just a planet or a solar system or even an isolated galaxy. We are a member of the local group. This entire family of galaxies is moving through the cosmic ocean together. We are part of a structure, a local community defined by the shared invisible thread of gravity that ties us all together across millions of light years. We have journeyed from our home planet to the stars across the expanse of our Milky Way galaxy, and even through the busy neighbourhoods of our local group and the Virgo supercluster. Each step has revealed a larger and more complex reality. Now we take the final and largest step back to view the entire observable universe. What we find is not chaos, but a staggering, beautiful and intricate pattern. This is the cosmic web, the largest structure in existence. When we look at the universe on this grandest of scales, we see that galaxies are not scattered randomly like sand tossed on a beach. Instead, they are organised. They draw together into immense glowing threads that stretch across the darkness, much like the intricate strands of a spider's web. These are the filaments of the universe. These filaments are mind-bogglingly enormous, stretching for hundreds of millions of light years. They are great winding rivers of light, and each point of light in them is not a star but an entire galaxy, or even a cluster of galaxies. Where these filaments cross and intersect, the concentration of matter becomes even greater. These intersections are called nodes or knots, and they form immense walls of galaxies. These are the superclusters we have talked about, the brightest and most crowded cities in the cosmos. These walls and filaments contain the vast majority of all the matter, all the stars and all the life, if any, exists elsewhere in the entire universe. But what holds this incredible structure together? The answer is something we cannot see. The web's design is drawn by an invisible architect, dark matter. The galaxies we see are like glowing lights decorating a vast invisible scaffolding. This scaffolding of dark matter provides the gravity that over billions of years has pulled ordinary matter into these long threads and dense knots, sculpting the universe into the web we see today. The visible universe is just the foam on the surface of a deep, invisible gravitational ocean. The most striking feature of any web is not just the threads, but the empty spaces in between them. The cosmic web is no different. Between the bright galaxy-filled filaments are the largest, darkest and loneliest places in the universe, the voids. These voids are bubbles of almost perfect emptiness, vast cosmic deserts that stretch for hundreds of millions of light years. The contrast between the filaments and the voids is profound. If the filaments are bustling bright cosmic highways, the voids are the silent dark countryside that stretches between them seemingly for an eternity. While a filament might contain tens of thousands of galaxies, a void of the same size might contain only a handful or perhaps none at all. This emptiness is not an accident. It is a direct consequence of gravity. For over 13 billion years, the universe has been expanding. In this same time, gravity has been pulling matter together. The regions that started with slightly more matter became the filaments. Gravity's pull grew stronger and stronger, pulling in more and more material like a snowball rolling downhill. But the regions that started with slightly less matter lost out. As their neighbours grew, their gravitational pull swept the area clean, pulling any nearby matter out of these regions and into the growing filaments. The rich got richer, forming the bright filaments, and the poor got poorer, becoming the empty voids. To be a galaxy inside a void is to be truly isolated. You would look out into the night sky and see almost nothing. The bright, teeming cities of galaxies we see would be so distant as to be completely invisible. The voids are a powerful reminder that the universe is defined just as much by its profound emptiness as it is by its concentrated light. So where do we fit into this grand cosmic map? We are not in one of the great voids that much is clear. Our sky is full of other galaxies. We are in fact part of a massive filament. We live inside a specific supercluster, a structure so vast it has its own name, Laniakea. This name comes from the Hawaiian language and it means immeasurable heaven. It is a fitting name for our home in the cosmos. Laniakea is not just a clump of galaxies, it is a structure defined by motion. It is a great cosmic river. Imagine a vast watershed on Earth where all the small streams and rivers flow together into one great river. Laniakea is just like that. It contains over 100,000 galaxies, including our own Milky Way, the Andromeda Galaxy, and the entire Virgo cluster. And every single one of these galaxies is moving. We are all flowing together, pulled by an immense gravitational current. We are a speck of dust, a single galaxy among 100,000, all caught in a cosmic tide. This river of galaxies is flowing towards a single common destination. We call this destination the Great Attractor. It is a massive concentration of gravity, a valley, in the fabric of space-time, and our entire supercluster, our entire immeasurable heaven is sliding downhill towards it. Laniakea itself is just one bright thread in the even larger cosmic web. It shows us our true place in the universe. We are not just on a planet or in a solar system or even in a galaxy. We are part of a flow, a single drop in a great gravitational river streaming through the darkness, as part of the largest, most magnificent structure we have ever discovered. For centuries we have studied the night sky, and we have become very, very good at understanding one thing: gravity. We know that the moon orbits the Earth. We know that the Earth orbits the Sun. The laws of gravity are precise. They predict that the farther you are from the central object, the slower you must travel. Mercury close to the Sun whips around in just 88 days. Neptune out in the darkness takes 165 years. If Neptune suddenly tried to move as fast as Mercury, the Sun's gravity would fail, and Neptune would be flung out of the solar system, lost to interstellar space. This is a fundamental rule. In the 1970s, astronomers began to apply this same simple rule to galaxies. Galaxies are not solid objects. They are vast, spinning collections of individual stars. Like our solar system, they have a bright, dense center. Therefore, the stars on the far outer edge of a galaxy far from the gravitational center should be moving slowly. But when astronomers pointed their telescopes at our neighbor, the Andromeda Galaxy, and then at others, they found something that was not just wrong, it was impossible. The stars on the outer edge were moving fast, shockingly fast. They were moving at the same speed as the stars near the center, and sometimes even faster. This was a moment of pure disbelief. It was like watching a merry-go-round spin so violently that the outer horses were moving at the speed of a bullet, yet they remained perfectly in place. According to every law of physics, we have these galaxies were spinning fast enough to tear themselves apart. The gravity from all the visible stars, all the glowing gas, all the dust we could measure was not nearly enough to act as the glue. The stars on the edge should have been thrown off like children letting go of a carousel, flying into the blackness of the intergalactic void. Our universe should be a graveyard of disintegrated galaxies, but it is not. The galaxies are stable, the beautiful spirals remain. This was the anomaly. It was a clue just like 3-Eye Atlas that told us we were missing something. And we were not missing something small. We were missing almost everything. If the stars aren't flying away, it means there is enough gravity. And if there is enough gravity, there must be more mass, more stuff than we can see. So scientists began a hunt for this missing mass. Maybe it was just things that are hard to see. Perhaps it was made of old burnt-out stars called brown dwarfs, or countless black holes, or maybe just vast cold clouds of gas that don't glow. They added it all up. They calculated the mass of every star, every planet, every gas cloud they could possibly find. And it was not enough. It was not even close. The math was relentless. To get the gravity needed to hold a galaxy together, you need about 5 times more stuff than we can account for. The conclusion was as terrifying as it was revolutionary. The vast majority of matter in the universe is invisible to us. It is a new kind of substance. It does not glow. It does not reflect light. It does not block light. Light passes right through it as if it isn't there. It does not interact with us in any way. You cannot touch it, you cannot taste it, and you cannot see it. The only reason we know it exists is because we can feel its gravity. They gave this phantom substance a name, dark matter. This isn't just a small correction to our models. When we look at the total budget of the universe, all the energy and matter that exist, the results are humbling. Everything you have ever seen, everyone you have ever known, every star in the sky, every planet, every grain of sand on Earth. All of this normal matter makes up only about 5% of the known universe. This invisible dark matter, this ghost makes up about 27%. The rest, a staggering 68%, is an even more mysterious force called dark energy, a story for another time. We are the strange exception, not the rule. The universe is not made of the same stuff we are. For a long time, dark matter was seen as just the glue that holds galaxies together. But the truth is far more profound. It is not just the glue, it is the architect. It is the invisible scaffolding that allowed us to exist in the first place. If we go back to the Big Bang, the universe was an almost perfectly smooth hot soup of gas. Our best computer models showed that the gravity from normal matter alone was not strong enough to pull itself together. The universe was expanding so fast that this gas would have just kept spreading out, getting thinner and thinner forever. The universe would have remained a cold, dark, boring fog of hydrogen. No stars, no galaxies, no us. But the dark matter was there, because it does not interact with light or heat. It was not pushed by the fire of the Big Bang. It was heavy and it was slow, and it began to clump together first. In the darkness of the early cosmos, it formed vast invisible networks like a three-dimensional spider web stretching across billions of light years. These invisible filaments created what we call gravity wells, deep pools of gravity in the middle of empty space. The normal matter, the gas that would one day become us, felt this pull. Like water spiraling down a drain, the hydrogen gas of the early universe was pulled into these invisible dark matter valleys. The gas collected, it compressed, and it ignited, forming the very first stars. These stars gathered into the first galaxies. What we see when we look at a galaxy is just the foam on the wave. We are seeing the little bit of normal matter that has settled in the center of a truly colossal invisible halo of dark matter. The machine of the galaxy, its stars, its spiral arms, is being guided and held in place by the ghost that surrounds it. We live our lives on a tiny planet in a solar system, in a galaxy that is itself just a small bit of luminous dust trapped in an invisible gravitational web. We are completely, totally, and utterly dominated by a substance that we do not understand and cannot find. Right now, billions of particles of this dark matter are likely streaming through your body through the Earth and back out the other side without leaving a single trace. We are living in a ghost's world, and now the greatest hunt in physics is on to build a trap deep underground, sensitive enough to finally catch one. If the discovery of dark matter felt like finding a strange invisible ghost in our cosmic house, the discovery of dark energy was like realizing the house itself is actively trying to push us out, expanding its own walls at an ever-increasing speed. For most of the 20th century, astronomers had a simple understanding of the universe's ultimate fate. After the initial explosion of the Big Bang, the universe was expanding. But just as a ball thrown into the air is pulled back down by Earth's gravity, scientists assumed that the collective gravity of all the matter in the universe, all the stars, all the galaxies, and even all that mysterious dark matter must be acting as a brake. The expansion, they reasoned, should be slowing down. The only question was whether it would slow down enough to eventually stop and collapse back in on itself in a big crunch, or if it was just slow down forever expanding but at an ever less enthusiastic rate. In the late 1990s, two separate teams of astronomers set out to measure exactly how much the universe was slowing down. To do this, they used a special kind of exploding star, a type Ia supernova, as a standard candle. These specific supernovae are incredibly useful because they all explode with almost exactly the same level of brightness. Because we know their true brightness, we can tell how far away they are by measuring how dim they appear to us. The dimmer the supernova, the farther away it is. Their plan was to look at very distant supernovae. The light from these explosions had travelled for billions of years to reach us, so it was showing us what the universe looked like in the distant past. By comparing the distance of these ancient supernovae with the distance of closer ones, they could map the expansion rate of the universe over time. They expected to see the expansion slowing. What they found was the single most profound and shocking discovery in modern cosmology. The distant supernovae were dimmer than they were supposed to be. They were not where they should have been. They were farther away than all the models predicted. The only way this could be possible was if the expansion of the universe was not slowing down at all. In fact, for the last 5 or 6 billion years, it has been accelerating. This was not a subtle effect. The universe is hitting the gas pedal. Imagine throwing a ball into the air and instead of it slowing down, it suddenly shoots upward faster and faster as if propelled by some unseen rocket. This is what our universe is doing. This discovery turned everything we thought we knew on its head. Gravity pulls, it brings things together. Oh. What could possibly be strong enough to overpower the gravity of the entire universe and push everything apart? Scientists gave this mysterious force a name: dark energy. Like dark matter, we call it dark because we have no idea what it is. It doesn't seem to interact with light or matter. We can't see it, we can't taste it, we can't bottle it. We only know it exists because we can see its effect on the very fabric of the universe. It is a force that seems to push. It is a perfect cosmic scale anti-gravity. The strangest part is where it seems to come from. Dark energy doesn't seem to come from any object in space. Instead, it appears to be a property of space itself. It is the energy of the vacuum, the energy of pure nothingness. And this emptiness is not empty at all. It is brimming with a repulsive energy. Here is the most terrifying part of the idea. As space expands, you get more space. And if dark energy is a property of space itself, then as the universe expands, you get more dark energy. Think about gravity. As galaxies get farther apart, their gravitational pull on each other gets weaker. But dark energy works the opposite way. As space expands, more of this repulsive energy is created, which in turn pushes space to expand even faster. This creates more space, which creates more dark energy, and so on. It is a runaway feedback loop. The universe is locked in a cycle of ever faster expansion driven by an energy that it creates just by existing. When we do the math, the numbers are staggering. If we add up all the normal matter, the stars, the planets, the gas and the us, it accounts for only about 5% of the total stuff in the universe. Dark matter, that invisible scaffolding, makes up about 27%. This new mysterious dark energy, this anti-gravity push from the vacuum, makes up the remaining 68%. We live in a universe where 95% of reality is made of two substances that we cannot see, cannot understand, and cannot explain. This discovery forces us to contemplate a future that is profoundly different from anything we had imagined. It is a future not of fire but of ice, not of collision but of isolation. As this hurried expansion continues, it is pushing distant galaxies away from us at incredible speeds. Galaxies that are already far away are being pushed away from us faster than the speed of light. Now, this doesn't break Einstein's rules. Nothing can move through space faster than light, but space itself can expand at any speed it wants. This creates a cosmic horizon, a boundary we can never cross. As the eons pass one by one, the galaxies we see in our night sky will be pushed beyond this horizon. Their light will be stretched by the expansion until the waves are so long they are undetectable. They will quite literally vanish from our view. First, the most distant clusters will fade to black, then the next closest. Over billions and trillions of years, the night sky will slowly be emptied. The rich, glittering tapestry of countless galactic islands will be snuffed out one by one. Our own little cluster of galaxies, the local group, which includes our Milky Way and the Andromeda Galaxy, is bound together by gravity. Gravity is strong enough on this local scale to overcome the dark energy push. Our cluster will survive. In fact, in about 4 billion years, the Milky Way and Andromeda are still on schedule to collide and merge into one giant supergalaxy, which some astronomers call Milkomeda. But that will be all. Imagine a future astronomer living on a planet within this giant merged galaxy, perhaps 100 billion years from now. When they look up at the night sky, what will they see? They will see the stars of their own galaxy, and beyond that, nothing. Just blackness, an endless, unchanging, terrifyingly empty void. There will be no evidence of other galaxies. There will be no leftover glow from the Big Bang, as that too will have been stretched into oblivion. These future astronomers will have no way of knowing that the universe was ever expanding. They will have no clue that a Big Bang ever happened. They will look out at their single island universe and conclude with perfect logic that this is all there is and all there ever was. They will be trapped alone in an accelerating darkness, completely unaware of the grand cosmic history that we are so privileged to see. We, it turns out, are living in a very special fleeting moment in the universe's long life. We live in the one era when the sky is still full of light, when we can still see our neighbours, and when the echoes of our creation are still visible. We are perhaps the only generation that will ever be able to piece together the full story. And as we look out at that sky, we are forced to confront the biggest mystery of all, a universe that is not only stranger than we imagine, but stranger than we can imagine, actively tearing itself apart, propelled by the energy of nothingness itself. Imagine you are watching a movie of the entire universe. You see galaxies like brilliant swirls of light, all moving away from each other. The vast emptiness of space seems to be getting even more vast. This is the universe as we see it today, a story of grand and lonely expansion. Now what if we took the remote control for this cosmic movie and pressed the rewind button? If we play the film in reverse, the expansion stops and becomes compression. The galaxies that are currently rushing apart would begin to fly back toward each other. The vast distances that separate us from our cosmic neighbours would shrink. As we keep our finger on the rewind button, the universe itself gets smaller, and as it gets smaller, it also gets more crowded. This isn't just about things getting closer. As you squeeze all that matter and energy into a smaller and smaller space, the temperature and pressure skyrocket. The film rewinds past the birth of the first stars, past the great clouds of gas that formed them. We rewind further, and the galaxies themselves dissolve their stars and dust, merging into a single uniform blindingly hot fog. We are rewinding past the moment the first atoms even formed. We keep going. All the matter in the cosmos, every star, every planet, every person, every speck of dust is crushed together. All the energy, every ray of light, every bit of heat is combined. We rewind until everything, all of space, all of time, all of reality as we know it converges. It all comes back together into a single infinitesimal point. This is the logical conclusion of our rewinding journey. If the universe is expanding, it must have expanded from something. That something is the beginning. This starting point, this beginning, is what we call the Big Bang. It is the most misunderstood name in all of science. When we hear bang, we think of a firecracker, or a bomb exploding in the middle of a room. We imagine a point of sound and shrapnel expanding outwards into the empty space around it. But this is not what happened. The Big Bang was not an explosion in space. It was the explosion or unfurling of space itself. Before this moment, there was no room for it to explode in. There was no outside. There was no before. Time and space are woven together into what we call space-time. And this fabric of reality is what came into existence in that first incredible moment. The universe didn't appear inside of anything. It is the thing that appeared, and its origin is almost impossible to comprehend. The entire universe we see today, with its hundreds of billions of galaxies, each containing hundreds of billions of stars, was once contained in a volume smaller than a single atom. Think about that. Everything you have ever seen, touched, or felt was compressed into a state of infinite density, infinite temperature. We call this a singularity. From that single point, space-time began to expand rapidly and violently. This expansion stretched the universe from the subatomic to the cosmic in a fraction of a second. It was this initial powerful stretching that gave the universe its size, its shape, and the fundamental properties that would eventually allow stars and much later life to form. The bang wasn't a noise, it was the sudden ongoing creation of all the room in the universe. For the first few 100,000 years, this new expanding universe was a truly chaotic place. It was unimaginably hot and dense, a roiling soup of fundamental particles and intense energy. It was so hot, in fact, that atoms couldn't even hold together. Electrons were ripped away from protons, creating a thick charged fog of particles. During this entire time, light in the form of photons was also present, but it couldn't travel. Every time a photon tried to move, it would immediately slam into one of these free-roaming electrons and be scattered in a new direction. The universe was opaque. If you could have somehow existed back then, you would have seen nothing but a blinding uniform white wall in every direction. But the universe kept expanding, and as it expanded, it cooled. Finally, after about 380,000 years, it reached a milestone. The temperature dropped just enough for the free-flying electrons to be captured by protons, forming the first stable neutral atoms, mostly hydrogen. This event changed everything. Suddenly, the fog cleared. With the electrons now locked into atoms, the photons were free. The light that had been trapped for 380,000 years was released, and it burst forth in all directions, free to travel across the cosmos forever. That ancient leftover light is still travelling today. It has been journeying across the universe for over 13.8 billion years. As it has travelled, the continued expansion of space has stretched it out, lowering its energy from a brilliant visible glow into the invisible low-energy microwave part of the spectrum. We call this the cosmic microwave background, or the CMB. This isn't just a theory, we can still see this light. When we build powerful radio telescopes and point them at any empty patch of sky, we find it. It comes from every direction, a faint persistent glow with a temperature of just 2.7 degrees above absolute zero. It is the oldest light in existence, the universe's own baby picture. It is the fossil radiation, the afterglow, the faint, beautiful echo of the creation of everything. We have travelled so far together. We have drifted through the veils of gas and dust where stars are born. We have stood at the violent, beautiful edge of a black hole, a place where time itself bends and breaks. We have watched galaxies collide their stars, passing like ghosts in the night. We have gone backward all the way to the very first second of creation, to the single explosive moment that began everything. And now our journey brings us to one final quiet question. It is perhaps the biggest question of all. We look up at the night sky. We know not just as a matter of faith, but as a matter of scientific measurement what is out there. Our own galaxy, the Milky Way, contains perhaps 400 billion stars. Our best calculations tell us that there are likely just as many planets, if not more. That is 400 billion chances for life just in our own cosmic home. But our galaxy is not alone. It is one of hundreds of billions of galaxies we can see. The numbers become so large they lose their meaning. There are more stars in the observable universe than there are grains of sand on all the beaches of planet Earth. There are trillions upon trillions of worlds. Given the sheer number of opportunities, given the billions of years the universe has had to experiment, the question becomes unavoidable. Why is it so quiet? With billions of star systems and billions of planets in the just right habitable zone, and billions of years for civilizations to rise, you would expect the sky to be full of activity. You would expect radio signals light from massive engineering projects, the hum of an interstellar economy. Instead, when we point our radio telescopes at the sky, we hear silence. We hear the whisper of radiation left over from the Big Bang, the static of distant pulsars, but we hear no messages. We hear no one. This profound stretching silence is known as the Fermi paradox. Named after the physicist Enrico Fermi, who supposedly asked it during a simple little lunch with colleagues, "Where is everybody?" The numbers say the sky should be full. Our observations say it is empty. This is the paradox. It is one of the most deep and reflective questions we can ask. It is not, as some might think, a frightening question. It does not mean we are in danger. Instead, it is a question that makes us feel very humble. It forces us to think about our own place in this massive silent cosmos. And what is the answer? The truth is we do not know, but we can think about the possibilities. Perhaps the first answer, the simplest one, is that life is just impossibly rare. Maybe the step from cooling chemicals in a warm pond into the first living cell is a jump so difficult, so statistically unlikely that it has only happened once. Maybe we are that one time. In a universe with 1,000 billion chances, we are the winning ticket. It would mean that we are, in a very real sense, a miracle. Or perhaps life is common, but the distance between stars is simply too great to overcome. The universe is vast, but it is also very old and very slow. The speed of light, the fastest anything can travel, is a cosmic speed limit. Even to our nearest neighbouring star, it would take a spacecraft thousands of years. Maybe civilizations rise and fall on their own planets like islands in an endless dark ocean, forever separated by a distance they cannot cross. They look up at the sky and wonder just as we do if they are alone. There is another, even more humbling thought. What if we are simply the first in the long life of the universe? Intelligent life had to begin at some point. Maybe the universe has only just now cooled down enough, the stars have lived long enough to create the heavy elements that life like us is finally possible. Perhaps we are the stars, the firstborn of the cosmos emerging into an empty universe that is waiting for consciousness. Or maybe, just maybe, we are not listening correctly. Maybe we are like a tribe in a remote jungle listening for the sound of drums while the sky above us is filled with radio and television signals we do not know how to interpret. A truly advanced civilization might communicate in ways we cannot even dream of, perhaps through gravity waves or neutrinos, or in dimensions we cannot perceive. The silence might just be our own inability to understand the conversation. Whatever the answer is, it makes our own existence, this moment, that much more valuable. If we are rare, then we are precious. If we are alone, then we are responsible. If we are first, then we are the pioneers. The silence of the universe does not make us small. Instead, it makes the fact that we are here thinking about it an event of cosmic importance. And so this great journey brings us back from the edge of the cosmos, back from the beginning of time, and all the way back into this room, back to the simple, quiet rhythm of our own breath. We have travelled to the ends of the universe and the limits of time, and in all that vastness, we have found that the most wondrous thing is not the exploding star or the spinning galaxy. It is us. It is the simple fact of our own awareness. We are the part of the universe that has woken up. We are the way the cosmos is able to know itself, to see its own beauty, and to ask its own questions. You, the person listening to this, are a collection of atoms forged in the heart of a long-dead star, and you have now become aware. The journey has been long, but now it is time to rest.